have here is a question which was asked in the GATE 2012 exam. The question is that a particle of mass m slides under the influence of gravity without friction along a parabolic path. Okay, particle is sliding under the influence of gravity in a parabolic path. Y is equal to ax square. That's the parabolic path equation. And what we need, with a is a constant, what we need to find out is the Lagrangian and Lagrange's equation of the motion. We have options in the question, but I'm not writing all those options because there is a Lagrangian and Lagrange's equation. That's 4 options, 8 options exactly. So I'm not going to write that all down. The first thing I'm going to do is that to find out the Lagrangian of the equation, Lagrangian of the particle. Okay, so Lagrangian is equal to T minus V. So T is the kinetic energy in the basic form in a 2-dimension. This is a 2-dimension which is of x and y axis. So in 2 dimensions, the basic Lagrangian kinetic energy will be half m into x dot square plus y dot square, and kinetic energy which will be equal to exactly mg and y, because y is the axis where gravity is acting. This is the basic form of the Lagrangian, which we can write using equations of kinetic and potential energy respectively. So first thing that we need to know is we need to know things based upon one generalized coordinate, which is as we are given the equation y is equal to ax square, which means dy by dx or dy by dt, of course, yes, is equal to 2ax into x dot, 2ax into x dot. So I'm going to substitute that in the case of the Lagrangian, which gives you half m into x dot square plus 2ax into x dot the whole square, which means 4a square x dot square, okay, minus mgy. So that's Lagrangian as it is given, as it is we have found out. So we got the Lagrangian. This is Lagrange's equation right here. And also I'm sorry about that, but we need to replace y also. Y is equal to ax square, so it will be ax square. So the Lagrangian will be this equation, okay. And the next thing that we need is to find out the Euler Lagrange's equation of motion, okay. So Euler Lagrange equation or Lagrange's equation of motion, we know the Lagrange's equation, which is known as d by dt of dou L by dou q dot minus dou L by dou q will be equal to 0. This is the Lagrange's equation, Euler Lagrange equation. So we need to find out dou L by dou q dot, and here it is the x dot, which means, okay, we can take the x dot, we can write half m, there is only x dot difference here, so we have to take the derivative of this whole thing, and this doesn't have any x dot dependence. So m x dot, derivative of x dot with respect to x dot is 2 x dot, right? So 2 x dot, it gives you 2 x dot minus or plus half m into 4ax square x dot will give you exactly the same m and 4ax square, 4a square x square and another x dot. Okay, that's what you get for dou L by dou x dot. Now d by dt of dou L by dou x dot will become time derivative of this. So the first part only has 1 x dot, and the x is also time dependent, so we need to take the derivative as a case of product rule here, okay. So here there is only 1 x dot dependence, here there is a x and x dot which are both time dependent. So the first thing I'm going to take is time derivative of this, and this will be cancelled. As you can see, 2 and 2 will be cancelled, and what we will get is mx double dot in this case, plus there is a 4ma square taken outside, and then there is x square and x dot which are both time dependent. So I'm going to take first function, which is x square, into time derivative the second, which is x double dot, plus second function, which is x dot, into time derivative of the first, 2x into x dot. So we've got that also. Now the next thing in the next component of the Euler Lagrange equation is equal to dou L by dou q, or in terms dou L by dou x. So in the Lagrangian there is two places where x dependence is there, here and here. So I'm going to take that, which is half m. I'm going to write down the constants outside for a square. We're going to cancel 4 and 2 later, and then for a square, and then there is x dependence here. So x dot also there is no dependence, x dot square is gone outside. Now okay, what I'm going to do is that okay, x dot is taken outside because there is no x there is only x square here, so it will be 2x here exactly, minus there is an x dependence here, so mg a into 2x here. So this is the dou L by dou x. Now I'm going to combine them both and write the Euler Lagrange equation, which is dy dt of dou L by dou x dot minus dou L by dou x is equal to mx double dot plus 4ma square into x square x double dot plus x dot into 2x into x dot minus dou L by dou x, which is equal to half m into 4a square x dot square into 2x minus, which becomes plus mga into 2mgax to be exact. Yes, this is the Euler Lagrange equation. As you can see right there, we can simplify it further by writing mx dot double dot can be taken outside of the whole, these two components. Mx double dot can be taken outside, no you cannot. Mx double dot can be taken outside from these two components, and then I can write 1 plus 4ma square x square plus 4ma square, which is there is a 2 also here, so 8ma square 8ma square x dot square into x minus half cancel, so it's 4ma square x dot square to x plus 2mgax. So that's the Euler Lagrange equation. You can see this is both the same, so I can take the difference here. I have already made things much neater here. This minus this is 8 minus 4, which is 4 ma square x dot square x plus 2mgax, which is a Lagrange equation which is equal to 0. So this is the equation of motion for the particle under the influence of gravity, which is in a parabolic path. So I have this could be in the option, or it's some derivative of this equation would be in the option. Some derivative with which I mean some interchanging coordinate constants and all that, so there won't be much difference. You can easily spot this. This is somewhat the simplest form I could find. Okay, so good luck. For more just visit t.me CSIR net physics.